Today we're talking about EdgeDB with Yury Selivanov, who is one of the creators, a co-founder of EdgeDB. Yury, thanks for coming on the show.
Thank you. Yeah, glad to be here.
We've talked over the years, and this is an exciting time to be talking about EdgeDB because you had your major announcement. At recording time, this is a week ago, but by the time this publishes, it'll probably be 6 weeks ago.
Yeah.
Congrats.
Yeah, we did have a pretty great day on Thursday, February 10th. We launched EdgeDB Live on YouTube. You guys can look it up. It's on our EdgeDB YouTube channel. It was a little bit silly, the beginning of it. We actually were figuring out how to exactly launch EdgeDB and how to make event even remotely climactic 10 minutes before the event. So things that could go wrong went wrong. For example, we wanted to have like an audio track playing along. We are typing like "Wake up, Neo." The time is now. HDB is waiting for you, and yeah, the sound was muted. So I think like a lot of people were watching us like at exactly 10 a.m. Pacific time, and like it's just silent, slow typing without like any soundtrack. But overall, I think people loved it. And while the event was ongoing, we posted to Hacker News, and I think 30 minutes in, we already hit the front page of Hacker News, and then we quickly rose to the top of Hacker News to the #1 spot. And we've been there for 13 hours, maybe 14. I mean, I went to sleep without checking, but we were #1 around like 11:30 p.m. And amassed 930 or 40 points, 300 comments or more. And yeah, what was kind of worrisome is that there was no negative comments in at all, like just words of encouragement and people being excited. Like I usually see some.
Hacker News isn't always a friendly place.
Yeah, exactly. And this time, like everybody was cheering, so we were super excited about this.
That's great. Well, congratulations. It was I missed the flub at the beginning, but maybe that lends authenticity. This is but the rest of it, what I did catch looked fantastic. So tell us about what EdgeDB is, so the audience is oriented around what we're discussing.
Yeah, so EdgeDB is a new database, and it's actually not just a new database. I believe that it defines a new category of databases. We call it graph-relational. We are coining this term, so don't go to Wikipedia just yet. It will be there, hopefully, soon, but there is no article about it right now. This is a new thing, and it's essentially an extension of relational model. It's just a couple of things, and we can go over them if you want. But the ultimate goal of EdgeDB is to just streamline the developer experience around dealing with the database to make it convenient. Like if you have a great tool, it almost disappears in your hand. You can just perform your task without noticing like any rough edges or anything. Just like natural extension of your hands essentially. With databases, it's not like that. Usually, like there are lots and lots of things for you to figure out and be super careful around. How do you deploy them? How do you write queries? How do you fetch data? What kind of middleware do you need to set up? All those questions, they are real and they actually slow you down. And with EdgeDB, we just want to basically remove all those aspects, like negative aspects, remove the drag essentially, and just give you a tool that can actually speed up your development process a lot by big factor.
The name graph-relational, I think, is kind of new to EdgeDB. I feel like I followed the project some, and I think in times past you've communicated that aspect, but not so concisely. Am I right, Yury? You've had various ways of kind of describing EdgeDB, and this seems the most succinct and in some ways compelling. I feel like you may have hit on something.
I have kind of two things that led us to inventing graph relational concept to share. The first one Dan Abramov, probably everybody knows him without an introduction. Dan Abramov and I had a conversation about React probably about a year ago. They were about to release a new version of React, and he was wondering how we handled Python 2 to Python 3 migration, which was actually quite painful. And after that, I surely introduced him to EdgeDB. I asked him, "Hey, let's have a follow-up call. I'll just tell you more about EdgeDB and like pick your brain on it. Maybe you will suggest me a few things." And he said that when they launched React, a lot of people, like, first of all, not a lot of people understood what React is, like immediately. Like it didn't click with the community like the first day. But then there was this almost random article about how React actually works, and that random article mentioned that, hey, there is this virtual DOM concept that React builds on top of. And then suddenly the community was buzzing. Oh my God, virtual DOM, this is the thing. This is the future. If it's not going to be React, it's going to be virtual DOM for sure. So I have to learn React now. So naturally, we started to look like, what is our virtual DOM in EdgeDB? Like what is an interesting aspect? Like how can we distill the value of EdgeDB into something like that is like 3 words long or something like that? And then just before releasing EdgeDB, Elvis, my co-founder, and I had a phone call, and we need to write a 1.0 announcement blog post. And that was actually quite stressful because we are building this project for like 10 years, and it's a huge thing. I mean, a lot of people from time to time ask us, like, is this a norm? Well, I mean, yes, it does some of the things that worms do, but it does so much more. Like it has standard libraries, own query language, protocol, client APIs. The API surface is just huge, and we are solving so many different problems at once. So what the hell do we tell in that 1.0 announcement blog post? How do we structure it? What do we do? So yeah, we had a conversation with Elvis for a couple of hours. Just okay, let's start from the first principle. What do we actually do at our company? What are we actually building? And then yeah, can we call it a relational database because it's kind of different from a classical relational database? And turns out that yes, we can. And I mean, we always knew that it's a relational database, of course, but just talking it through and distilling the exact modifications that we've done to it kind of laid the foundation for this terminology. And I mean, the initial idea of calling us graph-relational was coined internally by our dev advocate, Colin McDonald. And we liked the name immediately, but we didn't quite connect it properly to HTTP ideas. And then before writing this 1.0 blog post, after having this conversation, it was clear, crystal clear. We're building a graph-relational database. This is a new category. Let's define it. Let's open the door loudly and just say, yes, we're building graph-relational database, and here's what it can do for you.
And I suppose we should get to the history, we will in a moment, but I suppose part of the benefit of this 3-word phrase, as you mentioned, is that it hides, it's kind of an abstraction layer. It hides all the complexity. There's all this nuance you want to explain about the product and the features, I'm sure, and the React people did as well. But by leading with this phrase, it kind of encapsulates, maybe. You can define it, and it encapsulates all that terminology that you can get to eventually, as long as you understand this catchphrase.
Absolutely. And I mean, this name isn't absolutely flawless and perfect, because when people hear graph relational, they might be slightly confused and say, hey, so this is a graph database. And I mean, we are not Neo4j. We actually have strict schema, and we have relational foundations. So we are not a graph database. But conceptually, I mean, when you're programming, graphs is all you work with. Sometimes you don't realize it, but I mean, yes, if you work with objects, those objects are connected to each other. That's a graph. There is GraphQL after all. So the name actually makes sense, and I believe this only like slight imperfection of it, that some people might think that it's a graph database. I think it will not be a big deal in a relatively short time when people learn more about EdgeDB.
Good. Well, take us back. Tell us where this all started, Yury. 10 years you've been working on this. Is that right?
No, it's longer than that. It's
Oh,
embarrassingly
okay.
longer than that. So,
Well, let's bear it all for a moment.
so yeah, my co-founder Elvis and I, we met. I don't even know like how many years ago, maybe 13, maybe 14 years ago, at a small Canadian company that were building like a lead management system for big companies like Costco, Walmart, etc. And yeah, we when we met, there was a system, was V1 of that system, and pretty much immediately we started working on a new system, V2, and we tweaked lots of things, we implemented lots of things. It was interesting, it was cool, and then we started working on V3. And for V3, we did something special in terms of programming. Like most of the business logic was designed in a declarative way, and the application could be just compiled out of the description, and everything worked just amazingly well. Like we didn't have any bugs. Like we had to actually go and insert some bugs into production just to check that their reporting is working. It was crazy. Like we were perplexed. What's going on? Like we were writing this system for a year, and like it's just working flawlessly. Like no way, something is wrong. But it was a smooth launch. And back then we just realized, hey, we have this great synergy. We built this amazing tool. It's being used by big companies. So how about we just start a new company and try to build something? And we had absolutely no idea what we're going to build. It was around 2008. And yeah, we started the company. We called it Magic Stack. It was in Toronto, Canada. And yeah, the idea was, hey, let's run this software development boutique shop. And if something great comes to our mind, we implement it and transition to a product company. But we'll start with just software development. Somehow we were lucky enough to have great clients. We worked with Department of Defense, even though we were subcontractors, but we were working on some projects that were pretty interesting and pretty secret. We partnered with a Canadian company that was doing like behavioral simulations, business simulations for big companies like GE, Microsoft, etc. And we created a game, an iPad game, which simulated like a virtual university and led people to kind of discover how to run a university, how to expand it, etc. And it was powered by a super early version of EdgeDB. And as we were working on products like this and actually shipping them to pretty big companies, we realized that, hey, the internal stack that we're using at Magic Stack, it's and hence the name of the company, Magic Stack, it's pretty great. But the core feature of it is this data layer. And then we, at one day, we realized that, hey, yeah, we can actually build a database. We can actually capture the essence of this data layer, generalize it, make it language agnostic, not just like a Python framework. And yeah, it will be a database.
And your co-founder was on board. I mean, I think that this was. It sounds like you initially decided you wanted to work together and you wanted to build something, and you were building various things, and eventually you realized that what you both had passion around, or at least expertise in, was this core database framework.
Yeah, absolutely. I mean, he was the mastermind behind specifically like all data layer things, like how do we actually compile it to SQL, how do we design our schema. I mean, it was three of us in the core of this project, Elvis, our first employee Victor, and I, and everybody was involved to a certain degree. Closer to 2018, I think, it was basically three of us working almost full-time on EdgeDB. But I think without Elvis, this just wouldn't happen, because he had this early insight that dealing with worms is actually quite painful, and we should fix it.
It's interesting that you acknowledge that the insight was about the problem as opposed to the solution. Eventually, the subsequent insights are various ways of solving it, but the first insight was like, we need to this is painful.
Yeah, absolutely. I mean, both Elvis and I mean, first of all, we're developers, but second, we just hate writing code. I mean, we love writing good code, interesting code, but doing mundane things over and over again, it just kills the fun. And we wanted to have a fun job. So yeah, the whole idea of this data layer was to basically not repeat ourselves. I mean, if you're describing your model once and you have a description of this model, like your types and like relationships between your types, when you need to create, let's say, a form or a grid to do data entry or to display the data, it would be silly to just restate all this information just like from a different angle. So yeah, we heavily relied like on metaprogramming, etc. We had some projects that had tens different screens in admin panel and looked incredibly complex. But there was like, I don't know, 100 lines of code in them. And the rest was just meta files that just declaration files that just mapped your like UI and UI widgets to the data model. Everything else was just generated automatically. Those systems were quite impressive, and they further reinforced the idea that we are onto something with HDB, because HDB just allows this, it almost encourages this sort of programming.
Yeah, so you've been paying the bills for a decade by shipping some stuff to GE on occasion,
Yeah.
but ultimately building this data layer.
Yeah.
And at some point you decide this is the product or the kind of core idea. And when did, what does that shift look like?
We're actually doing lots of other things. Like we were deeply into open source starting around 2013, actually. So we used Python programming language. This is our tool of choice and been tool of choice for a long time. And around 2013, a core developer, Brad Cannon, announced that, hey, we have this PEP, Python enhancement proposal, and it's been around for years. Let's pick it up and let's implement it. Let's fix it, whatever. Let's accept it. I saw that announcement. I knew about this PEP. I was using the API it was describing, and I knew that this API was suboptimal and that it wouldn't actually work. So I picked up that stale PEP and updated it with a better API. I joined forces with Brad Cannon himself and with Larry Hastings. He's also a Python core developer. And we just brought this PEP up to speed. And a year later, I became Python core developer. Around that time, we started investing heavily in asynchronous programming. And internally at Magic Stack, we had this asynchronous IO framework. And Guido van Rossum, creator of Python language, also started working on asynchronous programming support in Python. And somehow it all happened that the small Canadian consulting company, ended up introducing async await syntax to Python programming language. We were kind of going and living and breathing open source for years now. It was mostly doing our open source Python work on the one hand, on the other hand, supporting ourselves with just developing software for clients, and then dedicating whatever time left to HDB development.
You mentioned something I want to quickly ask about, and then we'll go back to the rest. But you became a Python core developer. What does that mean? And how does that happen? I imagine there's a lot of people interested in open source that aren't really sure what the mechanics are to become a core developer.
Yeah, absolutely. Python is an interesting language, actually, because it's not designed by a committee. There is no big corporation behind Python that controls how it's been developed. And there are some upsides and there are some downsides. It's just what Python is. I would say there are about 30, maybe 40 developers of Python language that are just active, that exchange emails on the Python mailing lists. Usually it's Python dev and Python committers and Python ideas that write those Python enhancement proposals, that monitor our bug tracker, which is bugs.python.org. Try each bugs, fix them, review pull requests, etc. All those people usually have a commit bit, so they can just go and commit things. to the Python interpreter. And because it's just 3040 and the actual active core is even smaller, everybody knows each other. So it's almost like a club, but it's an open club. And this is very important to understand, that everybody actually is excited whenever someone else new joins, because managing a project like Python, which is just immense, it's immensely huge, it's complicated. It's number 3 or maybe now number 2 programming language in the world. It's just a complicated thing. So whenever someone is active on GitHub or on our mailing lists and starts contributing to the project, usually they are being noticed, and then you receive an email one day, hey, I noticed you've been active here and there. How about we promote you to be a core developer? You answer yes, and then there is a poll. We just ask, hey, is everybody comfortable with promoting this girl or a guy to be a Python core developer? If the poll is positive, and usually it is, then you become Python core developer. There are some perks to that. First of all, yes, you can now commit to Python itself, which is exhilarating. You're making changes that millions of people will see and experience. It's a great feeling. But then there are some other interesting things, like there is the conference called Pycon US, and it's a big event. I would say it's about 3,000 to 5,000 people every year meeting in one place. And 3 days before that conference, there is an event called Python Language Summit. And that event is run behind the closed doors. This is basically 1 day a year when all Python core developers meet and they can discuss the plan. What do we do next? Usually this event is later covered on sites like LWN, for example. Sometimes those like notes and articles leak to Hacker News and other sites. So I think a lot of people know about Python language core language summits, but it's an interesting perk of being a Python core developer.
Good. Thank you. Yeah, the not so secret summit. Very good.
Exactly.
All right. So you've developed this data framework layer you mentioned, but separately you've also been working on Python. You introduced async await, which is that seems like a whole big evolution in Python. Congratulations. And are those related, or are they kind of separate threads? So
they are related actually, and in an interesting way. So basically, we knew that when we started contributing to Python heavily, we knew that EdgeDB will become a thing, and I think we actually coined the name EdgeDB before us contributing async await and investing in the Python ecosystem. But we knew that it's going to happen, and we knew that the process is going to be painful because no way we can get all the details about the design right from the first attempt. So we knew that, hey, we have this compiler of our query language to SQL, and it's pretty complicated. Most likely we're going to be rewriting it several times. So we just had to stick to Python because we wouldn't be able to write this much code and refactor it this quickly if we chose C or even C++ or something like that. So we had to be using Python, and for that to happen, we also knew that, hey, there are certain requirements to EdgeDB. Like it must handle lots and lots of concurrent connections, and the cost of establishing a connection to the database should be super low. How do we do that? Well, apparently asynchronous programming is the answer, and that's why we started investing into it. And then we were thinking about our client APIs, like how a client API would look like in Python for EdgeDB. And we knew that we have to support the asynchronous clients as well. And back then, in Python, the answer wasn't obvious. Like, how do you have a transaction block, for example? You would have to basically copy and paste like 6 lines of code, like try, finally, create transaction, etc. So I just knew that, hey, this is not going to fly. This is way too verbose. And this is basically how our async await proposal was born, because we thought, hey, Python has this beautiful feature, a context manager, just say with context, then colon, and then you have your block. But there was no asynchronous equivalent of that. So we had to have like asynchronous context manager. Okay, how about async with? And then, oh, if we have async, we can have async await. This is how it all clicked. Then we actually we're thinking about performance. Okay, we have asynchronous I/O, but Python is still pretty slow. How can we speed it up? This is how UV Loop was born. And UV Loop is an interesting project. I know that a few years ago, when you were browsing Instagram, a lot of traffic was going through UV Loop, actually. Facebook picked up UV Loop super early and started using it internally, and then in some of the products. I don't know if they still use it. Maybe they are. But the project since then accumulated 8,000, maybe 9,000 stars. It's like a drop-in replacement for the built-in asynchronous core. You just one with basically 2 lines. You import UV Loop and then say UV Loop install, and your code just becomes 3 to 4 times faster. It works like magic. And yeah, it was created specifically for EdgeDB because we knew, hey, EdgeDB must be fast, but how do we do it with Python? Well, yeah, we need to accelerate it somehow. So yeah, a lot of our open source efforts were pretty much dictated by EdgeDB.
And do you, there's other approaches to accelerating Python, like binding Python or other bindings to other languages. Do you employ other those
We
tactics?
use them all.
Anything that can be done, we do.
Whatever can be used. I mean, we have pieces of Rust code in EdgeDB, and with time, we're gonna probably rewrite more and more of the core logic in Rust. Now that the data model is settled, now that we understand how do we compile our query language, we know the algorithms, now we can actually start investing into rewriting the code base in a lower level language. But yeah, we use Python. We compile Python basically to C in many different places, and basically all bottlenecks. And I mean, if you just look at benchmarks of EdgeDB, the overhead over vanilla Postgres is actually super low. So EdgeDB is actually quite fast. And yeah, I mean, Python is an implementation detail. People shouldn't notice or probably won't even know it's in Python. And I think we're doing pretty good job of keeping it just an implementation detail.
So at some point you decided EdgeDB was going to be a thing and we're working towards it. At some point you decided that it would be an open source launch. Maybe that was already clear. And also a company. You went and raised some money and pursued this kind of in earnest. Tell us how those steps unfolded.
Around 2018, we realized that, hey, we have to present EdgeDB to the broader community somehow. And Pycon US was happening in about a couple of months. So we just applied to become Pycon US sponsors. We booked a booth, and we knew that, hey, our first technology preview has to be released like right there. And we have to just show it to people and see what they tell us. So we printed 3,000 booklets for Pycon, booked a booth, printed like a bunch of swag. And we were actually finishing this technical preview, I think, almost a night before the conference opening. So yeah, that was our essentially first contact with the community when we showed EdgeDB for the first time. And the feedback was just super positive. I think we chatted with hundreds of people there, and everybody was excited. And when we came back to Toronto, the conference was in Cleveland. When we came back to Toronto, we just knew, okay, so now we just have to commit like 100% to make EdgeDB real. So over 1 year, we were just refining everything. We were refining the query language, the data model. We changed a bunch of things, focusing on DX. And in, I think, April or May 2019, we released EdgeDB Alpha 1. I think we hit Hacker News with it. And I already met with a few friends and a few fellow Canadian startup founders. So I got some introductions to VCs here in the Bay Area. And midsummer 2019, I started flying to San Francisco every couple of weeks or so, having meetings with people and just trying to race with what we had, an Alpha 1. Back then, I was pretty sure that we're going to launch 1.0 like half a year later, or a year later, or something like that. Unfortunately, it didn't go so fast. We are building a database. It is a pretty serious thing, so it took us longer than that. But yeah, in 2019, August 2019, we finally raised our seed round, led by Axel and specifically Dan Levine. We incorporated in 2019, I think it was September 25th. And yeah, early 2020, just before the pandemics, we moved to San Francisco with the goal to build our network, meet with people, participate in meetups and everything else. And then it was a total lockdown 3 weeks later.
Oh, that's terrible.
Yeah, it wasn't the best thing, but yeah, we were not alone in this mess.
Did you stay?
Yeah, we did. Climate is so much better in the Bay Area compared to Toronto, especially during winter time. So yeah, it was pretty enjoyable. I'm glad that we stayed.
Good. And after, not 6 months, but a couple years of work, we're now to the real launch, or we're closer to it.
Yeah. We launched 1.0 finally. After basically 2 years of just grinding through different issues, small incompatibilities, and just streamlining the DX a lot. We've built a lot of things over the past couple of years. EdgeDB can now be installed with essentially one command. We have great workflows, great tooling. We've fixed lots and lots of little quirks in the query language, in HQL, in the standard library. We worked heavily on our client API, so it was definitely a time well spent. But during this time, we were almost encouraging people not to use HTTP because we we knew that, hey, it's a relational database. If something goes wrong, businesses can be at stake. So we're always cautious with our messaging. Like, hey, this is an alpha quality product. Play with it. Report back, but don't build anything real with it just yet. And amazingly, I think we actually have had a pretty great core community. It's hard to put an exact number on it. I would say about 200 people or so. People who installed all those alpha releases, submitted bugs, and just communicated to us whatever pain points they had. So we were constantly refining the product, going through all those multiple pre-releases and multiple different release stages up until late 2021 when we released RC4, and it was clear, okay, this is time. And we spent about 1 month of just preparing for the 1.0 launch, updating the website, planning the live launch event, etc. Not really changing HTTP itself that much.
Well, that's great. I don't know that we've fully kind of articulated kind of the benefits of EdgeDB, so maybe we should spend a moment there. I think from the launch, I did see some interesting things on video, like making requests to the database come back with types on the return. The response object is fully typed, which seemed exciting. And what how do you describe to folks, all the value that's there, which I'm sure is
exactly. It's a list of bullet points essentially. It's a lot. So first of all, with EdgeDB, you have a strictly typed schema, and we've invested a lot of time to make this schema first development possible. So first of all, you describe your schema with a high level domain-specific language we call Sdl Schema Declaration language. It's very powerful. You can describe, we call them object types. Object types can link to other object types and have some properties attached to them. Object types can be treated as mixins, essentially. So you can mix object types with each other. That enables composition with HTTP, a composition that is not traditionally possible with any ORM or with any relational database. So now you have the schema, and the schema is just pretty much one-to-one mappable to your programming language of choice. It feels native to JavaScript, this object model, and feels native to Python or any other high-level programming language. So already you are not internally translating this mindset from objects to tables and relational data. The data model just matches what you're working with on a daily basis. And then we have a query language, HQL, and a lot of effort went into making HQL what it is today. If you just look at HQL, it looks like a child of SQL and GraphQL, as someone aptly put on Hacker News. And it's true to an extent. It's a declarative query language. It allows you to fetch hierarchies of objects, just like GraphQL. But what makes it different from GraphQL is that you can write analytical queries. And basically, the goal was always to build a database that can actually replace SQL. And in order for that to happen, you cannot just have this one big feature. Hey, I can request hierarchies of objects, or I can do that fast. To actually replace SQL properly, meaningfully, and have a shot at becoming like the next big query language, we had to essentially make sure that any type of query that SQL can do, HQL will be able to do as well, including analytics.
Yes,
exactly, including analytical queries, including fetching operations, everything. Like, if something is expressible in SQL and is harder to do, or isn't expressible in HQL, that was a bug to us.
Yeah.
And we were basically fixing and sometimes redesigning an aspect of the language. So HQL now looks kind of obvious. Like, I cannot believe that we spent so many years designing it, because it's so simple conceptually now. But yeah, its core property is that it's composable. So you can just pretty much refactor it, just like pure Python or JavaScript code. You can move things around, you can nest things, and everything just works. And the language has room to grow. Like, we'll introduce window functions eventually. We will introduce group by command in EdgeDB 2.0, which should come out around May 2022. So we'll continue adding those analytical capabilities. But the foundation of HQL is already more powerful than SQL in many regards. First of all, yes, it's composable. Second, you can express multiple different operations in one query, which is possible in SQL, but is extremely cumbersome. Like with HQL, you can just select multiple unrelated pieces of data and just receive them back in like one compact object arrangement, essentially, without any need to deduplicate your roles or anything like that. You can insert things, update things, sometimes unrelated things in one query. It's totally pipelinable, essentially. You can combine multiple unrelated queries into one query, and that query will be compiled under the hood to just one SQL query. And this is an interesting thing, because if it's a single query, you don't need like any explicit transaction. This query will be run atomically. So this ultimate composability of HQL, it doesn't actually make it easier for you to write it. That's true, but it also makes it quicker to execute for you. Just basically one round trip between your client and server. You can express so much now. And if you look at how ORMs traditionally do this, they usually fire lots and lots and lots of implicit hidden SQL queries, just inflating your communication cost with your database.
I'm starting to appreciate just how much work had to go into this, because you're right. An alternative to what you did is you could have built the client experience you wanted, and then built your own database, but you wouldn't have had all the benefits, the hardening that's come from Postgres.
Exactly. And boy, do we use Postgres to its full capabilities. We found, I think, 7 or 8 bugs in Postgres over the years. We were actually pushing it to its limits. In order to do this right, we had to get the fundamentals right, and that includes proper data model and the proper query language. And now we started to build more primitives on top of it. So for schema management, okay, so you can express your types in your application elegantly in EdgeDB schema, but then you need to evolve your application, add new features to it, right? So you add new types and you change your existing types. This is called schema migrations. So schema migrations are part of EdgeDB. They're just part of the core workflow. Database knows everything about migrations, about your schema, and it can do it like no other tool, essentially. Which means that you just learn the workflow of working with the schema once, and then it doesn't matter what language you're using. Either it's Go or, I don't know, Elixir or Python or JavaScript. It's always the same workflow. And then there are so many other aspects.
Yeah, it's impressive you call this, an alpha or a 1.0. I mean, schema migration sounds like something that I can imagine somebody saying, "Oh, we'll get to that later." You can use it for now, and maybe that'll be in 2 or 3.0.
Yeah.
So impressive that you had such a high bar on what folks would want, and I think it's probably going to lend to really great first impressions.
Hopefully, and I think this is what actually happened on our launch day, and in Hacker News comments as well. People mentioned it because it looks like a real thing that you can just start immediately building with. Because again, migrations is such a big pain point for users. So if we can get them right, it already elevates the entire offering to a new height, essentially. But this is sort of tip of the iceberg. So, okay, we have a schema, we have a query language, we have migrations, but then we had to think about the client APIs. How do we make them great? How do we make them composable? How do we integrate with TypeScript? How do we streamline the experience of installing EdgeDB on your machine locally, or just joining a project that already uses EdgeDB? With our command line tooling, this is just like one command line command. You just type EdgeDB project init after you git clone your, something from GitHub, and it does automatically everything for you. It bootstraps the proper version of EdgeDB, runs it. You can just type EdgeDB and connect to the database. It already has all the types in it, and everything is there, ready for you to just start working. So we basically were looking at the entire experience of working with EdgeDB. And this is what is so hard to explain when we are talking about EdgeDB. It's not just the new data model, graph-relational. It's not just the schema or migrations or the query language or libraries. It's all of this. We are trying to reimagine the entire experience of working with the relational database, not just in terms of ergonomics, but also in terms of performance and latencies and quality of service and composability, all of it. And this is why it took us so many years to just make sure that we ourselves understand what we're building, what we're capable of building, and how can we balance this 1.0 thing so that it's immediately usable and useful, and also serves as this proper foundation for us to just keep evolving things into the future.
How do you feel about, you mentioned that you're kind of a hybrid between GraphQL and SQL, and it's not even a fair comparison with GraphQL, because they're just to your point earlier, somebody decided here's what the developer experience could look like, here's a spec, go implement it yourself. And you went miles further, where you said, let's implement all the permutations of ways you could interact with this thing and support them. But looking at just the spec, I get the impression that you're kind of taking it another step further. Like, folks realize the value of some elements of the developer experience encapsulated in GraphQL, and you're saying, okay, and more, and here's other things you would want to do when you request data from a database.
Yeah, exactly. And by the way, GraphQL helped us a lot in the beginning. Most of the core principles of EdgeQL, like fetching of hierarchies of objects, we already had them when GraphQL was announced, essentially. But explaining why this is cool was tough. Like at some parties, we were talking to people and they were asking, hey, what are you working on? And we are like, we have this magical data layer. It can do this, this, and that. And they were looking at us with like empty eyes, not really following and getting the idea. And when GraphQL was announced a few months later, like everybody knew that, hey, this is a great thing. Potentially it can be used to create databases, not just for stitching APIs together. Suddenly everybody realized, hey, this ability of just fetch an object tree is super useful. And then it became much easier for us to explain HDB to our peers.
Yes. No, that would be a lot easier. And I suppose it also builds on their other open source projects that follow, have kind of have taken similar approaches. I don't know if you feel akin to things like Hasura or dgraph that have also kind of are GraphQL first, some of them relying on Postgres as well. But again, it almost feels like you've kind of continued to iterate and take things further.
Yeah, exactly.
In both cases.
Yeah, we just continued pushing. And by the way, I love Hasura. I think it's an amazing product. But with HDB, yeah, we just wanted to basically see how we can streamline creating of new projects, essentially. Like, what if you had no idea that other databases existed? What if you had no idea that Postgres is a thing, or MS SQL is a thing? Mm-hmm. How do we take it from there? Essentially, what would a database look like if it was designed in 2010 or 2020, right? And this is kind of an interesting thing, because on the one hand, it allowed us to explore so much in terms of functionality and where we can push things forward. On the other thing, I believe it might be a little bit challenging for us, because with HDB, you have to start things new. So it's for greenfield projects, not brownfield projects.
Yeah.
So yeah, it's an interesting dilemma.
Yeah. And then maybe shifting gears a little bit, and we should be wrapping up soon. This is one of our longer interviews, Yury. I'm just fascinated, so I could keep going, but I should respect your calendar time. The cloud has kind of messed up what we think of as a database to a degree, and I think in some cases databases look more like back-end platforms, and people start bundling features into so-called databases, authentication, authorization patterns, storage and functions. And do you feel like EdgeDB needs to do some of those things, or is there a purity to being just the structured data storage?
It absolutely has to. When we pitch EdgeDB from time to time to people, we say that look at those big companies like Facebook, Uber. They all have these data layers, and those data layers are amazing. Usually, they can do caching for you. They can do querying, multiple different aspects, and they make people's jobs easier. And this is why Facebook and other companies are able to ship amazing products, because they have this data layer custom tailored for their business, and it does so much more than just like, I don't know, MySQL library. So we describe HDB as basically being a data platform for you to speed up your development and give you a tool that only big, huge unicorn companies were able to afford before. So we have to go further than just give you an opportunity to query data. People struggle with auth. It's like one of those computer science programs, like naming cache and validation and auth. It's always broken. Sign-up forms are painful to implement. And we have to offer that. And we already kind of go there, because EdgeDB provides GraphQL out of the box. So we already kind of go beyond what a typical database gives you out of the box. We already give you GraphQL. In some time, we'll start adding more integration to our future cloud offering, just streamlining and just removing the pain points one by one. So yeah, I'm fairly optimistic about that. I'm fairly optimistic about many things, like WASM, for example. It can be an interesting fit for HDB. yeah, whatever it takes to make it possible for someone to just instantly become like this 20x developer, 10x developer, some multiplier developer, we should do that. We should give people this powerful tool.
Well, it has to be really exciting, Yuri, to be working on something for so long, to have had this vision and to be, marching along this path for so long, and then to have all these people show up and say, "Yeah, that's exactly what I want." Whereas it's been my whole life, which is going back to our very first discussion on this call, the response from Hacker News. I mean, everyone just seemed, like you said, unanimously positive. I've never seen that before.
Right. Yeah. This was great. Let's just hope that we'll be able to continue building on this gradually and continue finding this way of presenting EdgeDB and actually explaining what it can do for people. Because again, the product is just big. It's huge, and it changes so many things we do about software development. So yeah, I hope that people will be encouraged to spend some time, check it out, get familiar with it, and start being excited about EdgeDB.
Good. Anything we didn't cover today you wanted to discuss? And if not, maybe you can tell people how they can get involved, or kind of the state of the product, what they can look forward to.
I'll say a couple of things. First of all, check out EdgeDB. You don't have to build a production system with it, but you can at least check it out and start using it. Maybe you can introduce it in your company, automate some microservice with it. I don't know. It's a database. You can build so many amazing things with it. We will launch a cloud version, a hosted version of EdgeDB, hopefully in May 2022. Maybe it's going to be just free tier, maybe something more than that. But this is our goal, at least. We're working hard, all hands on deck, on just making this hosted version of EdgeDB a reality. And second thing, because we spent so much time talking about Python and the open source ecosystem, I would like to just encourage everybody to just go and contribute to Python. It's an open source project, not really baked by any big company or corporation. It runs by volunteers, essentially. So if you ever are annoyed with Python that something is poorly documented or something isn't working properly, file a bug, submit a pull request. That's going to be amazing. And if you do a bunch of those, you'll be promoted to a Python core developer. And it's an amazing thing to be.
You heard it here, folks. Yury has given you the path to stardom within Python. Thanks so much, Yury, for coming on the show today. And thank you for the gift of EdgeDB that you've given us over the last decade, and the world is finally getting to appreciate.
Oh, thank you for kind words.
You can find today's show notes and past episodes at contributor.fyi. Until next time, I'm Eric Anderson, and this has been Contributor.